Everyone, welcome to AB Calculus. This is Nicholas JMV, and today we're going to talk about the 2002 AB4 free response question. Let's go ahead and dive right into this. So the graph of the function f is shown above in red here. It consists of two line segments, and let g be the function given by this definition. Okay, let's find g of -1, g prime of -1, and g double prime of -1. Okay, so the first thing I like to do is if I had, I start with the prime and the second derivative first. I know if I take the derivative of the left side, I have to take the derivative of this thing. And what that implies, it implies that g prime of x is actually equal to f of x. So this red graph is also my derivative graph. So when I want to find g prime of -1, well, that means I'm looking at f of -1. So I look on my graph at -1, and there I go. I see that value, that y value is actually just 0. Okay, so if I know that g prime of x is equal to f of x, I also know that g double prime of x is equal to f prime of x. And the reason being is if I take the derivative of the left side here, I have to take the derivative of the right. So what they're looking at, and what that means here, is that if g double prime of -1, okay, g double prime of -1 is equal to the slope at -1. Okay, so the slope of this line, our point -1 is here, and we need the slope of that line. The slope of that line is actually 3. You can use -2, -3, and 0, 3 to check that. They're actually a slope of 3 and a slope of -3. So our slope there is 3. I do the last one first here. The first one last, I should say, g of -1. So g of -1 is equal to the integral from 0 to -1 of f of t. And this is going to be the definite integral by using geometry. The first thing you have to notice is that limit of integration. Okay, they're backwards. We want the smaller number, so we're going to negate it. We're going to take the opposite, and then we're going to switch our limits of integration. So I'm going to go ahead and do that there, right here. And now I can go ahead and take the area. And I have a triangle. We're looking at this triangle right here. Okay, and then let's see if I can follow that red line right there. So the area of a triangle, it's going to be negative for that -1/2. The base is 1, the height is 3, so 1 by 3. And so we know that the area is going to be -3/2. So there's 3 points right there on the FRQ. All right, so let's go down to part B. For what values of x on the open interval is g increasing? Okay, so g is increasing. So if g is the original function, we know that g prime of x equals f of x from the first part. Okay, so what this means is that if g prime of x equals f of x, if that value is greater than 0, that means positive. That means if g prime is positive, that means the function is increasing. So we need to look on our graph where g prime of x is positive. Okay, so we have to look at the graph and say, okay, what values on our graph do you see where the derivative is above the x-axis? And it goes from here to here, this v. So from -1 to 1, g prime is above the x-axis, and so g prime is positive. That means g is going to be increasing. So this happens on the interval from -1 to 1. Okay, the explanation's here, so that's 2 more points you'd have. Now, concave down. G is concave down, okay, when g double prime of x is less than 0. Okay, when g double prime of x is less than 0. It also means that if the slope, okay, so if g double prime, remember from the beginning, g double prime of x is equal to f prime of x. So less than 0, that means negative. So that's negative, right? Okay, so where do we see where f prime is going to be less than 0? So where do we see a slope that's less than 0? So let's go back up and look at our graph. So we can erase essentially this part. And let's look at now all the way from here to here. And notice if this is g prime of x, if I take the derivative of g prime of x, this green line, if I take the slope of that line, that's negative. Okay, so that's where our second derivative is negative, and that's where we have something that's concave down. Okay, so this happens, g is concave down when f prime of x is negative, which happens on the interval from 0 to 2. Okay, you can also say it's negative, you can say it's 0 to 2, it's less than 0, and it's where it's also decreasing. You can also say that too, that's the same idea. Okay, when f prime of x is decreasing, that's a negative slope. Okay, now part D, they ask us to sketch this graph. So we've got so much stuff that we get from this graph, and let's just try to write down what we have. We know the graph is concave up. Okay, let's look. Concave up, second derivative when g double prime of x is greater than 0. Let's look at that. So go back up. From negative 2 to 0, there's concave up. We already just discussed the green line being concave down. So we need to have a graph that's concave up from negative 2 to 0. That's concave up. We have concave down from 0 to 2. Okay, now let's look at a couple more features. Okay, it would be nice to know what's going on at the endpoints. Okay, like negative 2 and 2. So if we looked at this triangle from negative 2 and this triangle, looks symmetrical. Okay, what about this triangle and this triangle? What's that total area? Okay. So we can look and say these are symmetrical, negative, positive area. They're the same. It's going to, from negative 2 to 0, it's going to be 0. And same thing here. So when we look at adding some extra values, we know that g of negative 2, okay, is going to equal 0. We know that g of 2 is going to equal 0 based on those triangles from above that I drew. And the other thing we can look at is the last point here, maybe g of 0. Okay, and when we look at g of 0, it's going from 0 to 0 of f of t dt by definition from part A, and that equals 0. So when we graph this, we get negative 2 is 0, 2 is 0, and this is 0. Now let's go back up, and if we look at, got a lot going on in this graph. If we look at, let me clean some of this up really quick. Negative 1 and 1 right here, a positive derivative to a negative derivative. Okay, so that's going to be a max. Okay, and at negative 1, a negative derivative to a positive derivative, that's a minimum. Okay, so let's try to draw this. So from negative 2 to 0, we have concave up, and at 1 we have a minimum somewhere, and then like a maximum somewhere up here for positive 1. So our graph is going to look something like this, as a general sketch of that graph. Okay, so that is 2002 AB4. If you have any questions or comments, please let me know, and we'll see you next time.